Today we're going to factor some trinomials. We have several different types of trinomials that we'll factor today, some involving trinomials with a leading coefficient of 1, some without, and then some where we need to make sure we factor out a greatest common factor. So first, let's start with a trinomial that has a leading coefficient of 1. So if we have, let's say, n squared plus 6n plus 8. So we have a trinomial. Trinomial means that it has 3 terms. We can see here that we have 3 terms. And our leading coefficient here is actually a 1. You can see that this will follow all of our rules where we have a trinomial with a leading coefficient of 1. And that rule states we're going to see, is there a number that multiplies to give me the outside and adds to give me the inside? Okay? And the outside number in this case is that 8, and the inside number is 6. Okay, so now let's start thinking here. What is a number, or what are 2 numbers that multiply to give me 8 and add to give me 6? Well, if this is something that you can't do in your head, just go ahead over here to the right or wherever. Take your factors of 8. We have 1 times 8 and 2 times 4. Anything after that is just going to repeat. We would then have 4 times 2 and 1 times 8. So these are going to be the 2 factors. Now, if we look, the outside sign is positive and the inside sign is positive. That means that both of these numbers need to be positive. So we write both of these numbers as positive 1 and positive 8 and positive 2 and positive 4. Now we can see here that our positive 2 and positive 4 is going to add to give us the 6 in the inside. So once we find our factor, since it's a leading coefficient of 1, we're going to have 2 factors, both beginning with n. And now at the end, we're going to put the 2 factors that we found that multiply to give me a positive 8 and add to give me the positive 6. So we end up with n plus 2 and n plus 4. Okay, and if you want to see how this works, if we work backwards to get the trinomial, we would use the distributive property to make sure that it's correct. So we would take n times n, which is n squared, and then n times 4, which is just plus 4n. Now at this point there's nothing else to multiply that into, so we move to the 2. 2 times n is plus 2n, and 2 times 4 is plus 8. When we combine like terms in the middle here, we end up with n squared plus 6n plus 8. So we can see that we have factored correctly here. But now, what if we have a different problem here? We have a trinomial that does not have a leading coefficient of 1. Let's say that we have 5n squared plus 10n plus 20. In this case, we need to make sure that we have a 1 in the front. That's where our rule comes in, where we can say what multiplies to give me the outside and adds to give me the inside. Well, the problem here is we have a 5. So the first thing that we always need to do is we need to factor out a greatest common factor. Well, if possible. In this case, we have a greatest common factor, or something that multiplies to give me all 3 numbers, would be a 5. We can see that 5 times 1 gives me the 5 in front, 5 times 2 gives me the 10 in the middle, and then 5 times 4 would give me the 20. So when we say factor it, we bring it out front, we put everything else in parentheses. So you take that leading coefficient, 5 divided by 5 is 1n squared, plus now we have 10 divided by 5, which would be 2n, and then 20 divided by 5 would be plus 4. So now, we actually can see that there is a trinomial right here. This trinomial has a leading coefficient of 1 now. So we're going to try to factor that. Right now, we're just going to ignore the 5 out front. We can't just do away with it. We just leave it out front and leave it alone right now. So now, let's see. What multiplies to give me 4 and adds to give me 2? Is there anything that's possible to give me a positive 4 and positive 2? Well, in this case, I can see I'm going to write my factors, 1 times 4 and 2 times 2. We can see here that the outside is positive, the inside is positive, so both signs here will be positive. And does 1 plus 4 equal 2? No. Does 2 plus 2 equal 2, and we can say no. So I can see here at this point I have factored this as far as I possibly can. At this point, if I wanted to find what we call zeros, so instead of being factored we find it zeros, we would have to use what's known as the quadratic equation. Okay, so like I said, in this case we were able to factor out the greatest common factor and was able to leave it alone in terms of a trinomial. Now, what if we were trying to get one that works? Let's see if I can think of one that'll work for us. What about if we did 5v squared minus 30v plus 40? Okay, hopefully this one will work. Once again, we can see that there is a greatest common factor here. Just like the problem above, we have this greatest common factor. Factor out the 5. That leaves me with v squared minus 30 divided by 5 is 6v plus 40 divided by 5 is positive 8. So now at this point we're going to see, is there anything that multiplies to give me a positive 8 and adds to give me the negative 6 on the inside? So we write our factors out here. That would be 1 times 8 and 2 times 4. In this case it's a little bit different because we have a positive number on the outside and a negative number on the inside. And our rule says what multiplies to give me the outside and adds to get the inside. Well, there's only one way for us to be able to multiply two numbers together and get a positive number and get a negative in the inside. That's for both numbers to be negative. So we can see that both of these have to be negative because two negative numbers multiplied together gives me the positive on the outside we need. Now let's look. Is there anything here that adds together to give me that negative 6? Well, negative 2 plus negative 4, if you owe $2 and you borrow 4 more, you still owe $6. We can see that that's going to give us the negative in the inside that we look for. So I write the 5 on the outside. Both factors will start with the v, or whatever that variable might be that we're using, in this case v, and then we write the two numbers that we found that multiply to give us an 8 and add to give us the negative 6. In this case it would be v minus 2 and v minus 4. So our final answer, if we broke this down into linear factors, which is our goal, would be 5 times v minus 2 times v minus 4. Okay? And now, the last step, this is what kids struggle with the most. We're going to have a trinomial now that doesn't have a leading coefficient of 1, and on top of that, it doesn't have a greatest common factor that we can multiply out. So let me write one here. For example, we have 2n squared plus 3n minus 9. Okay, so we have a trinomial. We need to try to get a 1 in the front. And our first rule is factor out a greatest common factor. And I can see there is not a greatest common factor between 2, 3, and 9. Meaning there's not a common number that multiplies to give me these three numbers other than 1. So in this case, we're going to have to use a method that I like to call bottoms up. Okay? And you'll see why it's called bottoms up as I get to the end. But the first thing is we need to get that leading coefficient to be a 1. So we kind of manipulate our equation here. We take this 2 and we multiply it to the end. So I'm going to multiply by a 2. Okay? So when I multiply that, we're going to get rid of that 2 in the front, and now it becomes n squared plus 3n minus negative 9 times that positive 2 that we're multiplying there gives me the negative 18. And now we've kind of manipulated this trinomial to look like it needs to be able to use our rule for what multiplies to give me the end and adds to give me the inside. So we need to write numbers that multiply to give me negative, or just 18, and then we can determine the signs later. So that would be 1 and 18, 2 and 9, and 3 and 6. There's not anything else that I can think of. So let me erase this dot I had out front. So let's see. We have a negative number on the outside. So the only way to multiply to get negative is for one to be positive and one to be negative. And then we have a positive on the inside. So when we add numbers for it to stay positive, if one's positive and negative, the larger number has to be positive. So in this case, we know that the largest number has to be positive, so the smallest number needs to be negative. So let's see. When we add these together, which one will give me the positive 3 on the inside? So if I take negative 3 plus 6, I can see that's going to give me the positive 3 in the inside. So we can now use the factors of negative 3 and 6. we write this as n minus 3, just like we did earlier, times n plus 6. Well, some of you will forget to do this last step with bottoms up. Some of you will stop and leave it like this. And you're actually going to be very close. You've done the hardest part, but you're still going to be wrong. At this point, to make it algebraically sound, since we multiplied by a 2 to start, we actually have to divide it back out now. So I'm going to take this 2 and I'm going to divide it by the number part. Okay? So if I take that and I divide it by the number part, the next step is to reduce the fractions if it's possible. So we can see that here that negative 3 halves will not reduce. So since it will not reduce, we're going to bring it the bottom up. That's where the name bottoms up comes from. So when I say bring it up, we're taking that 2 there and we're bringing it in front of the n. So this factor now, since it will not reduce, will become 2n minus 3. Okay? So now if we look at this other factor, n plus 6 divided by 2, I can see that 6 divided by 2 will reduce, and we can see that reduces to 3, so the factor there becomes n plus 3. Okay? If you don't trust your work, you can check yourself using distributive properties. Since this is a new method and some of you may not follow, let's go ahead and check to make sure. So we have 2n times n. That would be 2n squared. Okay? Then the next thing is take that 2n and multiply it by 3. That would give me the plus 6n in the middle. Nothing else to multiply the 2n to, so I'm going to take this negative 3 and multiply it to an n. That's going to be the minus 3n in the middle. And then minus negative 3 times 9 is going, or negative 3 times 3, sorry, is negative 9. When I combine like terms here, we end up with 2n squared minus 3n, plus 3n minus 9. And if I look here, this is the exact same thing that we started with, so we have factored it correctly. Thank you all, guys. If you need any help, come by and see me. This is Coach Watts at Center Point High School, room 110.